Hi, I'm James Cage, and this is my project for CS50AI, the traffic project. I built a sequential neural network to identify the traffic signs. You can see the structure of the model on the left. The output is at 43 different nodes, one for each sign. The input size is not shown, and I don't demonstrate the actual labels or input size here, but I will demonstrate the actual working of the project, which should imply that those are correct. Let's take a look at how I arrived at my final model. I started by using the code from the class example modified for the dimensions of the pictures in the directory. I had a few issues in that the model I created would not learn. I believe at some point the size of the different layers weren't compatible. I found that adding batch normalization layers helped with that, enabled the network to learn, and gave me good results. I believe that I added these batch normalization layers after pairs of convolution and pooling layers. From that, I started experimenting with the activation functions. I found that at the final layer, the SmartMax, or SoftMax rather, was the best algorithm. ReLU layers at the final had some very odd effects on the model. Essentially, it just stopped learning after epoch 3, went a little flaky. In the internal layers, the convolution layers, and the hidden layers of the model, the activation functions, SoftMax, ReLU, both would work, but SoftMax gave lower accuracy and higher loss than ReLU at those layers. So I decided, or I found the best results were ReLU at all levels other than the ending layer, which was SoftMax. As far as the number of convolution and pooling layers, I found that 2 convolution pooling layer pairs worked best for me. A third layer did not generate any significant accuracy, and if you do additional pooling layers, as we'll see in a second, or higher pooling filter size, you actually get down to a lower number of nodes, which doesn't seem to give you a lot of good accuracy. As far as the convolution layers, I read around different blogs online to find what I should be trying to do here with image recognition. One blog recommended that subsequent layers be a little bit larger to allow for additional insights inside the network. So I started with 64 and 128 nodes on the convolution layers, and I then started moving up and down. I was getting great results there. I moved down to 16 and 32, so that is to say 16 nodes at the initial layer and 32 at the next layer, and saw faster performance with no appreciable loss of accuracy. I then played around with pooling layers. Any pooling filter size higher than 2 by 2 started cutting the number of nodes available to the point where the model just wasn't working as well anymore. I did play with dropout, and I found that I tried multiple dropout layers first, like after each convolution pooling pair, after the internal layer, and and at the final output layer. And I found that just one layer at the output seemed to give improved, or seemed to give the same accuracy and low levels of loss without consuming a lot of resources. So that was much faster. As far as hidden layers, I tried multiple hidden layers, but one hidden layer of 128 nodes seemed to give the best trade-off between accuracy and performance. As we can see on the right side of the model, in this particular run, I had about 8% loss with an accuracy of about 98%. That's about a little bit less than average. It's gone as high as 99% and 5% loss, but it's definitely in the range. Thank you very much for reviewing my project.